Okay, so I'm going to talk to you about SQL Server, sort of an introductory course. Cost threshold for parallelism we're going to talk over, maximum degrees of parallelism. We're going to look at execution plans, using set statistics, reading the statistics, and most importantly, logical reads. We're going to look at scans and seeks. We're going to look at a lookup, looking at the memory allocation, and also looking at the indexes. So let's start this off. So I've got a database called the Playground, and inside here I've got a users table. You can ignore numbers. So I've provided you a script here that you just run. This will populate the users table with 1 million rows, 1 million users, and that's the data we're going to look at. So there you go. So it's only selected the first 1,000, but there is 1 million in there. Okay, well, we can actually prove to you. So I've just freshly installed this, not installed, but run this. So yeah, 1 million rows. Okay, so we can close the startup, the session setup file, which I've already run to give me the data. And then scroll to the top of this. I'm just going to walk through it, basically read the comments and run through it and sort of explain things. So we'll first of all run this. You don't run the whole script. We're just going to highlight sections and go through it that way. So I'll shrink that as well. Okay, so let's first make sure the database is in 2017 mode. We can do this to turn off the newer features, which can confuse the results that we're going to go through. Primarily, I'm aware of adaptive memory grants and adaptive joins, which are in 2019. So if you're using 2019 and you don't do this, you may get adaptive memory grants and adaptive joins, which will confuse the matter a bit. So we'll run this to put the database in 2017 mode. Okay, so we're going to start talking about scans and seeks initially. And basically, you know, what happens when you run some SQL queries. So let's run this simple select that you'll have all seen. With any luck, we will get some data back as it's randomly generated when we ran the startup example. So let's just go and say select all the users where their creation date is the 1st of the 1st 2020. So if we run this, we get 396 rows down here. We can see them all here. So now you may think, okay, I now know SQL. I can do a select statement, but there's a lot more to it, and we're going to delve sort of a bit deeper into it under the hood. So the questions you need to ask yourself are, how long did the query take? So at a glance, we can look at the bottom right down here. But it's not great for accuracy. It says it took 0 seconds, but it must have taken some time. How much CPU was used? How much data was read to fulfill this query? And how efficient was SQL Server at getting the data we needed? Without doing anything else, we don't know any of these things. So let's start investigating. Let's look at the actual execution plan. First click the Include Actual Execution Plan icon, or Control M and run it again. So what I'm going to do is press this up here, Include Actual Execution Plan, and then I'm going to run it. Okay, and what we get now is we get an execution plan tab. So when we look at the execution plan, which is this thing here, we can see SQL Server has done a clustered index scan, and we can see this down here. You see it says clustered index scan. So this means that it had to scan the whole table, all 1 million rows, to just pull back a handful of results. We have to hover over the icon to see this. So at the moment, if you look at that, you think, okay, it's only got 396 rows, but that's how many rows were returned. If we hover over it and look at the 6th row down, we can see number of rows read 1 million. So it scanned the whole 1 million rows to get you your 396 actual records back. So my numbers in here will differ from yours as they've differed now. So originally when I ran this, I had 445 rows. Now I've got 396. If we hover over the clustered index scan, we can see those numbers. We also see a estimated subtree cost, which is sort of near the middle further up, but it'll disappear if I go to it. But you can see it's 92.87. And also the estimated number of rows read was 1,000,000, so it was spot on for estimating. So one other thing we notice is that the query has gone parallel. This can be seen by looking at the racing stripes, so the double arrows against each operator. The estimated subtree cost is what is used to inform SQL Server if it should try and go parallel, in this case because it is over 50 on my machine. So if we hover over that again, we can see the estimated subtree cost was 92.87, so that's over 50. But this leads me on now, so why 50? So this parallelism leads me on to the following two important settings. So we've got a thing called Ctfp, and that stands for cost threshold for parallelism. So when we initially get a SQL instance, we should set this to 50 in most cases and not the default of 5. So when you get it out the box, it will actually default to 5. And this was quite a surprise to me when I learned it, because not many people that I've spoken to ever knew of changing this. But when you get out the box, it's 5. What this value means, it was only a good number for the 80s and 90s, and I believe it was like the time it took to execute on somebody's old machine, it took 5 seconds. But having a low number will mean there are more queries going parallel when you don't need this, and this value now needs to be increased with the power of our machines and CPUs. They're a lot more powerful than they were in the 80s and 90s. If this is not the case on any environments, then it should be changed. So what I'm going to show you is, if you can see the end results, I'll mention that in a minute. So we can go into the database, right click on it, go to properties, and we can click on, I believe, advanced, and you can see cost threshold for parallelism is 50 on mine. So on yours it may be 5 if you've never changed it. And basically what that means is more of your queries will be going parallel when in actual fact they don't need to. And you may be asking yourself, well, why is that an issue? So later on, not in this session, but from my learning and watching the Brent Ozar stuff, you can see sort of the side effects of leaving it 5. So in this case, if you were to run this command, spblitz since startup, you need to have spblitz installed, which I'm not sure I have. We'll see. I may have it. If I don't, it's okay, but it'll print out weight statistics, so the highest weights will be at the top. So if you see CX packet and CX consumer as one of the top results grouped sort of together, that's a sign that lots of your queries are going parallel when they may not need to. To change this, change the Ctfp to 50 will push these weight stats down after some time. So you don't want all your queries going parallel. I'm going to stop that because it seems to be struggling a bit. Okay, so yeah, you should always set to a sensible default, and 50 is quite a sensible value. Leaving it 5 means lots of your queries are going to go or try and go parallel, and that takes up extra resources. If we actually run that query again, here we go. I think it was taking time because I had execution plans on. If we run that again, we can actually see there's a gather stream. So this has been broken out into other let's have a look. I'll show you here. If you right click and go to properties, there should be number of rows read. Here you go, threads. You can see thread 1, 2, 3, and 4. So this work was split across 4 threads. And I believe I'll get onto that actually. So next we'll talk about maximum degrees of parallelism. So maximum degrees of parallelism is used to inform SQL Server of how many CPU cores it can use. The rule of thumb is half the number of CPUs on your machine. So if you have 8 cores, then it should be set to 4. This by default is 0, so SQL Server will use all available cores. You can imagine using all cores could be a bad thing, as some cores need to be used for other processes and the operating system. The two values can be changed by right-clicking. So again, MAXDOP, if it's set to 0 by default, it'll use all available cores. If we go into here and exactly the same place as the other one, actually advanced, you can see maximum degrees of parallelism is 4. I've got 8 cores, so I set it to 4. I don't think it can be a little bit higher than half, but it shouldn't be all of your cores. And as you can see, there's the cost threshold for parallelism. So now we're aware of these things, setting them to sensible values. We can sort of move on. All right, so we can delve deeper into this by right-clicking the clustered index and selecting the properties. Yes, so I'm talking about, if we go to properties, so the actual number of rows read for execution. Here you go. So we got 396 rows back, and we can see thread 0 is the master thread, so that spawns all the 4 other threads. So thread 1 found 101, thread 2 found 95, 3 94, and thread 4 found 106. So all of those are found, and then they're sent via this gather stream, grouped together, and you get your results of 396 rows in this case. So you'll also notice that there is a missing index, but we will get to that shortly. So it's just interesting to see the threads. 0 is the spawning thread, and then the other sort of worker threads are getting all the stuff together and then giving them back. So let's get more detail around this query. So this is my favorite statement now. Very simple. If you highlight this, set statistics IO and time on, nothing really happens initially, but now when we run this query, what we will see, so we still get our execution plan because we've got that on, but in the messages tab, you will see that we've got more output. But I won't jump the gun because I most probably explain this here. So after this is run, let's have a look at the messages tab, which we're looking at now. You will see that we have detailed timings and extra information about what SQL Server did to get the results. So the most important thing to look at is the logical reads. So here, you see this logical reads? We can see that it did, in this case, 128,519 logical reads. What this means is that it had to read that many 8 kilobyte pages. SQL Server stores data in 8 kilobyte pages. These pages are stored in a hierarchy called a B tree. So you can see each one of these are what represents. One represents an 8 kilobyte page. So you can see how much data is in there. So from the details above, we now know that I have 1 million rows that are in 128,000 logical reads. From this, we can surmise that we ran the query. That when we ran the query, we need to read 128 megabytes of data. So this is quite a lot to run that one query that we see here. It needed a gigabyte of, had to read in a gigabyte of data. So also look at the CPU time. So we can see the CPU time is here, and the elapsed time. You will notice that it finishes, in my example, 190, but here 224 milliseconds, but actually took 436, or in our case 514 milliseconds of CPU. This is also a sign that the query went parallel, because the CPU time is more than the elapsed time, and you can't fit, squash time unless you've got CPUs. So we've done quite a bit of work in half the amount of time. So with this, we now have a better answers to our questions. As for how efficient SQL Server was, we can say that it was not hugely efficient, as we had to scan the whole table. So we've had to scan it, and as we saw here, we saw an index scan, and when we hovered over it, we saw 1 million rows need to be scanned, and those 1 million rows are in these 128,000 logical reads. So let's make it faster. Let's look at the recommended index again. So this is what SQL Server oh, here we go. We can actually right click on that and do missing index details, and there's our missing index that it's recommending. You have to put your name there and check what it's recommending. But we will carry on reading what I've put here. Firstly, we should never just add it without looking at what it is doing. So in this case, we for sure don't want the bio column. Here it's wanting to put the bio column as an include, as this is an nvarchar 4000. So what Clippy is recommending is that we basically copy the whole table, so the users table, and index by the creation date. And this is not recommended. Might be nothing wrong with the creation date, but basically we're making a copy of the whole original table, which in this case we've seen is a gigabyte. So we're creating an index that is a gigabyte, and that's not how you should use indexes. Indexes should be small. They shouldn't have nvarchar 4000 columns. They should be smaller data types. I believe Brentos are recommended nvarchar 200, but when you go over that, then you've got to start really paying attention. An index should have the minimal amount of data to make it run as fast and as sensible as can be. Because we only get back a handful of data, we won't mind looking this up afterwards. So I'll show you this after we've added the index. So even though Mr. Clippy recommended this index, we're going to take half of what he said. We're going to create it on the created date, but we're not going to include anything, because the includes we can do with a lookup. So I'm going to run this. I'm going to turn off the execution plan. So what I've commented here, this line informs SQL Server to create an index as fast as possible. So you remember our friend MAXDOP, maximum degrees of parallelism. We set that to 0, so we say use all available cores to create this index, so it should be created faster with any luck. And then Brentosa was also using online off, so I added that in here. But I've been using MAXDOP, but not much of this in my actual work. So all an index is a cut down B tree of the original table. It is sorted by the fields defined. In this case, the created date, because we've had that, it's going to be sorted by the created date. So this will allow us to jump into the point that we are interested in and just get the data we need without scanning the whole table. And as you can see, the query is looking for the created date. So hopefully now we won't scan the whole table. We'll use this index, jump to that date, and then start reading just that data in that date range. So let's now run it. Okay, so it's run. So let's have a look at the execution plan, but I need to turn it on. So I'll run it again. And yeah, look at the execution plan. So that's changed now. You remember the other, they didn't have this lookup. We had parallel icons. We can see that the execution plan has changed. It is now using an index seek. See here it says index seek, and it's using our non-clustered index that we just created, ix created date. There it, see, that name matches that. It also now does a key lookup, so this is the key lookup, as the index does not contain all the data we need. So it's used this index and got 396 rows back. If you now look at the number of rows read, it's only read 396. If you remember the previous one, we did 1 million row reads, so it's reduced a lot with that index. The only problem is this index isn't known as a covering index. A covering index would have all the other columns like Clippy was recommending, but then we're basically copying the original table, and it's not worth the effort then. So instead it's doing 396 lookups to the original table and getting the extra data it needs. So I'll just carry on reading from here. So it now uses the seek, as I mentioned. It uses a key lookup, and it doesn't contain, so the key lookup, as the index doesn't contain all the data we need. So returning all the data the query needs is called a covering index, as I mentioned. But as I stated, this is something we don't want to do, as the bio column is a large column, and we need to keep indexes to a minimum to make them as fast as possible. Remember, this is the logical reads, so the less 8 kilobyte pages we read, the faster SQL Server will be. So key lookups are not a bad thing, so in this case, if it's a small number. So if you're doing thousands or tens of thousands of lookups, then you may need a covering index. But you could also ask yourself, should I be using pagination and batching in this case? Most cases, when surfacing data to users, it makes sense to use pagination, and hence you will only do lookups for that page of data. So, give me 100, I'll do 100 lookups, 500, it's no problem. Even 1,000, might be okay. You will also note that it no longer goes parallel, so we don't see any racing stripes now. This is a good thing, as SQL Server deemed it less work. If you remember the other one, it deemed it, the subtree cost was 92. So let's look at the statistics. We can see this by looking at the subtree cost. Yeah, so if we hover over this, you can see estimated subtree cost is 1.3. There you go, in that little window. So let's look at the statistics. We can see this by looking at the subtree cost. So yeah, logical reads compared to the original. So yeah, we're going to go back into here and we're going to look here. So if you remember, the logical reads in the original one were 128,000. We've now dropped them down, in this case, to 1621. My examples will differ. As you can see, that was a little bit more, but it's a drastic drop. So here are the after and here's the before, and we can actually see the CPU time has dropped drastically, and also the elapsed time is a little bit quicker as well for our data, which is good. So we're just putting less work on SQL, so SQL will now be able to run many more of these than it can of these. Okay, so that's good. We've sped it up a lot. You can see now, well, in our case, look, it took 0 milliseconds of CPU and 156 milliseconds to execute to return 396 rows that you need. So I'm going to move on to memory allocation now. So let's remove the index and take a step back. So we're going to get rid of our index. So let's run this query. So it's a bit different than the other one. We're going to say select everything from the users, but we want them ordered and creation date descending. So let's run it and see what happens. So I've put a comment here. It says it takes 11 seconds when I ran it. So let's see how long it takes. It may take longer. Hopefully we've got execution plans on. So yeah, it's taking quite a bit of time now. There you go. So it took 18 seconds to return all 1 million rows. So there you go. You can see 1 million rows being pulled back. And they should be ordered in by date order now. So we should have creation date, that is. So the newest at the top and the oldest at the bottom. So let's look at the memory grant. So by right-clicking the select in the execution plan, so we can right-click this and then click Properties. Yep, you will also, so you can also hover over it to do this. If you hover over it, you can see a memory grant, in this case, of 4,669 megabytes. So over 4.5 gigabytes of memory was required to run this query. And we can also go in here, memory grant info. So these are all in kilobytes, I believe. So I think requested memory, granted memory, here you go. So that's kilobytes, megabytes, yep, gig. So 4.7 gigabytes of memory was required in order to run this query, which is a lot. So what we see is that SQL Server has allocated, so these differed from when I ran them, 2.5 to 4 gigabytes, but actually you've just seen that we've got even more than that now. On my old work machine, so I was getting 500 megabytes, but my whole machine was running out of memory, so it couldn't allocate enough. But in this case, because I'm not running anything, it's able to allocate that much. So if you had a lot running on here and it couldn't get that much memory, it would give you a smaller allocation, and then you would struggle further on. So looking at the properties to see the memory grant, we can also see the desired memory, which is a lot more. So we can right click again, go to properties. See, desired memory is even more. That's 5 gigabytes. It would really like that much, but it was only granted that much. So let's move on. So SQL Server will allocate a maximum of a quarter of its allocated memory per query. So if you have 20 gigabytes of memory, then you can only run 4 queries if they require 5 gigabytes. So you can see this now being an issue. We can only ever run 4 queries at any one time. And that's just one query, let alone the other hundreds of things that are trying to get in. So you can see this is going to cause a bottleneck and issues. So how can we make this better, and why is the memory grant so big? So what SQL Server does for big columns like our bio column here, which is an nvarchar 4000, SQL Server estimates that the column will be half full. So you can imagine in a real world like Stack Overflow that a comment may only be a few words and never 2,000 characters. So note that when we add the order by, this initiates the memory grant. So yeah, you can see here the order by, that's what's actually initiating that memory grant. If you didn't have that order by, it wouldn't initiate that memory grant and wouldn't ask for 4.5 gigabytes. Because it needs, I'll read this again, so that when we add the order by, this initiated the memory grant. The SQL Server needed somewhere to sort the data. It's because we're sorting by this. So what happens when we just get the columns we want? So the previous query we said select star, didn't we? So let's do, I want the user ID, the first name, and the date of birth. So if we run that, we can see that is done. So let's have a look at the memory grant now. Oh, it's not done. It is done now. I was waiting for that. Okay, let's look at the memory grant. So the memory grant has dropped to 147 megabytes. This is a drastic difference and goes to show that you should only ever pull back the fields you need. So don't select star when you only need 3 columns in this case. So we've gone from 4.5 gigabytes down to 147 megabytes. So we can run a lot more of these than we can of the other query. So we've had a bit of a whirlwind going through this, but what I've shown you, we've talked about cost threshold for parallelism and setting that to a sane default, which is 50. So I'd recommend you go and do that. Maximum degrees of parallelism, set that to half your CPU, or at least not all of your CPU cores. We've looked at the execution plans, these wonderful things here with loads of details, and you can hover over and look at the properties for memory grants. We've looked at the statistics, which is really useful. That's one of my most favorite features, always looking at logical reads. You've also got physical reads. There's other things here that you can ignore most of the time, but physical reads can be quite interesting. If you've not run the query before and it's not in memory, then you'll see that you'll get physical reads as well, because it's loading it into memory, and then the logical reads are the 8 kilobyte pages that are in memory. And then I believe Enterprise Edition, you also have read aheads, which is supposedly some clever stuff where it can get the data before it needs it, but I don't think many of us have Enterprise Edition of SQL Server. But I have seen my local do this sometimes, so maybe local development is Enterprise, I don't know. But really useful for logical reads, CPU time, and also elapsed time, really useful. We talked about scans and seek, how we saw the original query was scanning 1 million rows, but we added that index and it turned into a seek using that index, and it was doing loads less logical reads, which I can scroll back up to possibly if if I can find it. Create the non-clustered index. Here you go. Yes, the original 128,000. After adding that index, we got it down to 1080. CPU time dropped drastically, and elapsed time dropped a little bit. So that was good. We looked at lookups. Lookups are not a bad thing. You know, you don't have to include everything in your indexes because you make them bigger. Brent Ozar recommends that you should have maximum of 5 indexes per table, a maximum, so don't aim for 5 if you don't need them, and 5 columns, so 5 and 5 includes. So when you create a non-clustered index like Clippy recommended, you can have, so on users, create this index, you could have 5 columns in there, and then you could include 5 there. But you don't want to add too many because these makes indexes bigger, and you know, the bigger they are, more pages they take, so it's more logical reads. But yeah, always useful to add and learn about indexes. We also looked at the memory allocation, so when you do a select star for an nvarchar 4000, SQL Server thinks that half of that data will be full because it has to estimate it. It can't read it all. There are statistics, not these statistics I showed you through, but if you've never run a query, SQL Server will generate statistics, which we can maybe go through in another session. And yes, I mentioned indexes as well. So there's so much more in-depth detail we can go into, but for now I thought this would be really useful starter. Get the groundwork in place and have a play with this set statistics. I know most of our queries are not going to be this simple, but it gives you the good groundwork in actually, you know, investigating your current queries, and then running them. And as we can see, yeah, with that index we get good logical reads. So yeah, and I suppose unless you've run this a few times, you won't know what's a good value and a bad, but you saw before it was 128,000 logical reads, 128,000 8 kilobyte pages are read. Now it's down to 1,621. So yeah, if you can get that down even smaller, then great, but thousands or millions of logical reads are going to create slow queries for you. So this sort of screen goes hand in hand with the execution plan, where you can hover over, see how many rows were read. You can hover over these lines and actually see how much data has been sent back. So that says we've sent back 396 rows of data, and then we had to do 396 lookups. This was all then sent back to the server. You can see actually Mr. Clippy is still recommending we create an index on this, but this is why you shouldn't just add these. You have to understand them. And we've created on created date, and we're happy for it to do the lookup because we don't want to just copy the original table. We'll get no real benefit from that. So yes, I hope you've enjoyed that. And if you have, I'll try and do a parameter sniffing one, I think. Maybe some statistics, and I've also done temporal table one. So yeah, I shall see you all later. Thank you.